Hello students, in this class we will learn how we can find the sum of all the terms present in a GP. Okay, so let us study how we can find all the terms present in a GP. Here we consider a GP as A plus AR plus AR square plus AR cube plus continuing plus A into R to the power of n minus 1, where first term A1 equals to A, common ratio equals to R, and this is the nth term, that is An equals to A into R to the power of n minus 1. Okay, so here we consider the general form of a GP, that is A plus AR plus AR squared plus AR cube plus continuing plus A into R to the power of n minus 1, where first term A1 is A, common ratio is smaller, and the nth term is A into R to the power of n minus 1. Okay. Let the sum of the GP or of this GP be Sn, because there are n numbers of terms, that is why we consider the sum of all the terms of this GP as Sn. So therefore we can write Sn equals to A plus AR plus AR squared plus AR cube plus continuing plus A into R to the power of n minus 1. Now if we, this is number 1. Now if we multiply both sides of this by this common ratio small r, then we get R into Sn equals to AR plus AR squared plus AR cube plus AR to the power 4 plus continuing plus A into R to the power of n. Now if we multiply all the multiply both sides by this common ratio R, then we get R into Sn equals to AR plus AR squared plus AR cube plus AR to the power 4 plus continuing, and the last term will be A into R to the power of n. Multiplying both sides by R. Subtracting one from 2, we get R into Sn. R into Sn means AR plus AR square plus AR cube plus A into R to the power 4 plus continuing plus A into R to the power n. And Sn means first term of Sn is A. That is why A plus. When we subtract 1 from 2, then we have to arrange the like terms. Okay, that is why R into Sn is this and Sn is A plus AR square plus AR cube plus continuing plus this, and at the time of subtracting we have to arrange these terms by this way. Here the second term is AR, which is similar with this first term of R into Sn. Second term is A into R square. Third term is A into R cube. Fourth term is A into R to the power 4 plus continuing plus A into R to the power n the previous term of this is A into R to the power of n minus 1, which is similar with this term. Okay, so this is the arrangement of similar terms. That means when we want to subtract relation 1 from relation 2, then we have to arrange the like terms. So after arranging we get plus into minus, 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 there is no term, minus. We can cancel this. So therefore, in the left hand side there will be R into Sn minus Sn, and in the right hand side there is A into R to the power n minus A. Now we can take Sn as the common factor, and after taking Sn as the common factor, the rest of the term will be R minus 1, and in the right hand side there is A as the common factor, and the rest of the term is R to the power n minus 1. Thus we get Sn equals to A into R to the power n minus 1 whole divided by R minus 1. Okay. So this is the representation of Sn. That means when we want to find the sum of n numbers of terms of a GP, then we can write S of n is equals to A into R to the power of n minus 1 whole divided by R minus 1. We can use this formula we can use this formula when r is greater than 1. Again, Sn equals to a into r to the power n minus 1 by r minus 1 can be written as Sn equals to a into minus of 1 minus r to the power n by minus of 1 minus r. Okay. This implies Sn equals to minus a into 1 minus r to the power n by 1 minus minus of 1 minus r. Multiplying numerator and denominator both by minus, we get plus a into 1 minus r to the power n by 1 minus r. So this implies Sn equals to a into 1 minus r to the power n by 1 minus r. So when r is lesser than 1, then we can use this formula, that is Sn equals to a into 1 minus r to the power n by 1 minus r. Okay. So Sn equals to a into r to the power n minus 1 whole divided by r minus 1 when r is greater than 1, and Sn equals to a into 1 minus r to the power n by 1 minus r when r is less than 1, where a is the first term and common ratio is r. Okay. Now, if this Gp continues up to infinite terms, that is S of infinity equals to a plus ar plus ar squared plus ar cube plus continuing up to infinity, when r is lesser than 1 and first term a1 is equals to a, then we can write S of infinity equals to a into 1 minus r to the power infinity whole divided by 1 minus r. Now, if this Gp continues up to infinite terms, that means a plus ar square plus ar cube plus continuing up to infinity, where common ratio is lesser than 1 and first term is a, then we can represent the sum of all that terms by S infinity, and in this case we get S of infinity equals to a into 1 minus r to the power infinity whole divided by 1 minus r. By applying this formula of Sn, okay. since r is lesser than 1, r to the power infinity tends to 0. This symbol represents tends to 0. As an example, when r equals to half, then r square equals to 1 by 4, r cube equals to 1 by 8, r to the power 4 equals to 1 by 16. That is, the value of r square, r cube, r to the power 4 gradually decreases, and this representation when continues up to infinite terms, that is, when we want to find r infinity, then this value will be nearly equals to 0. That is why we can write r to the power infinity tends to 0. Okay, that means when r is lesser than 1, or strictly when r belongs to -1 to 1, then r to the power infinity tends to 0. Okay, so by applying this concept, we can write s of infinity equals to a into 1 minus 0 by 1 minus r. This implies s of infinity equals to a by 1 minus r. Okay, that means when our GP continues up to infinite terms where the common ratio is lesser than 1, that means common ratio r belongs to -1 to +1, then we can write the sum of all the terms, that is s infinity is equals to a by 1 minus r. Okay, so these are the three forms. This is first form when r is greater than 1, this is second form when r is lesser than 1, and this is third form. That means the GP continues up to infinite terms and the common ratio is lesser than 1. That means common ratio r belongs to -1 to +1. Then we can write this form. Okay. Here we consider a problem. Okay, in this problem, fourth term and seventh term of a GP are given. They are 24 and 192. We have to find the sum of its 10 terms. That means we have to find the sum of first 10 terms of this GP. Okay, so to find the sum of in terms of a GP, we have to know the first term and the common ratio. That is why with the help of these conditions, that is fourth term is 24 and seventh term is 192, with the help of this condition, first of all we have to find the common ratio and the first term of this GP. Solution. Given fourth term, that is A4 equals to 24, and seventh term, that is A7 equals to 192. we have to find sum of 10 terms of this GP, that is S10. Okay. Let the first term and the common ratio of the GP be A and R respectively. So therefore, A4 equals to 24 imply A1 into R to the power of 4 minus 1 equals to 24 by the formula of nth term, that is An equals to A1 into R to the power of n minus 1, where R is the common ratio. So A into R to the power of 4, R A into R cube equals to 24, because we consider first term as A. That is why we replace this A1 by A. Since first term A1 equals to A. This is number 1, and A7 equals to 192 imply A1 into R to the power of 7 minus 1 equals to 192. This imply A into R to the power 6 equals to 192, because first term A1 is A. Now dividing 2 by 1, we get A into R to the power 6 by A R cube equals to 192 by 24, cancelling A and R to the power 6 by R cube, we get R cube. Then 24 and 192, we get 8. So this imply R cube equals to 8. So this imply R cube equals to 2 cube. This imply R equals to 2 by the formula of exponent. Since x to the power p equals to y to the power p, imply x equals to p, x equals to y. By this exponent formula, we can write R cube equals to 2 cube as R equals to 2. Putting R equals to 2 in 1, we get A into 2 cube equals to 24. This imply A into 8 equals to 24. This imply A equals to 24 by 8. Cancelling 24 by 8, we get 3. So this imply A equals to 3. Okay. So by these two given condition, that is fourth term of this GP is 24 and seventh term of this GP is 192, we find the first term A equals to 3 and the common ratio R equals to 2. Okay. So since R is greater than 1, so to find the sum of 10 terms of this GP, we have to use this formula. Therefore, sum of 10 terms of this GP S10 is equals to A into R to the power 10 minus 1 whole divided by r minus 1 equals to 3 into r means 2. 2 to the power 10 minus 1 whole divided by 2 minus 1, 3 into 2 to the power 10. 2 to the power 10 means 1024 minus 1 whole divided by 1. 3 into 1023 equals to 3069. So this is the way by which we can find the sum of first 10 terms of a GP when some conditions are given. Here the conditions are the first term and the seventh term which are given. Okay. In problem number 2, we have to find, there are two problems. Okay. In the for both of these problems we have to find the sum up to n terms. Okay. If we follow these problems, then they are different types of. In the first problem, the terms are 4, 44, 444, and by this way this series of value continues. And in the second problem, the series of value are 0.6 plus 0.6 0.06 plus 0.006 plus 0.0006 plus continuing. Okay. Generally, they are not like the general GP kind of problem, but we have to convert this problem as a GP problem when we want to find the sum of n terms of this GP. Okay, so let us study how we can find the sum of this series. Solution. Solution 1. Here 4 plus 44 plus 444 plus continuing up to n terms can be written as, so here all these terms contains multiple of 4. That is why we can take 4 as the common factor from all these terms at a time. So when we take 4 as the common factor, then the rest of the terms will be 1 plus 11 plus 111 plus continuing up to n terms. Now, if we multiply all these terms by 10 and then balance this by this way, then we will get 9 plus 99 plus 999 plus continuing up to n terms. We multiply all these terms by n, and to balance this we divide this 4 by 9. Okay. Now we can write 9 as 10 minus 1, 99 as 100 minus 1, 100 means 10 square, so 10 square minus 1, 999 as 1000 minus 1. 1000 means 10 cube. So 10 cube minus 1. So this represents first term. This represents second term. This represents third term. And by this way, if this series continues, then the nth term will be 10 to the power n minus 1. Okay. Now, we can find an arrangement by this way. 10 plus 10 square plus 10 cube plus continuing plus 10 to the power n. And then minus 1, minus 1, minus 1 plus continuing up to n times minus 1. And then when we take minus as the common factor, then there will be 1 plus 1 plus 1 plus continuing up to n terms. Okay. So we can arrange this by this way, and this arrangement help us to get a special arrangement. In the first arrangement, the terms are like this way: 10, 10 square, 10 cube plus continuing 10 to the power n. So this forms a GP where the first term is 10. Common ratio R is 10 square by 10 equals to 10. And this represents a constant AP. So first term A1 equals to 10 and common ratio R is also 10. That is why we can write S of n is equals to A1 into R to the power n minus 1 whole divided by R minus 1 equals to 10 into 10 to the power n minus 1 by 10 minus 1 equals to 10 into 10 to the power n minus 1 by 9. So sum of this is equals to 10 into 10 to the power n minus 1 whole divided by 9 minus sum of n numbers of 1 will give n. This will give 4 by 9 into 10 into 10 to the power n will give 10 to the power of n plus 1 minus 10 minus 9n whole divided by 9. Nothing is here means 1 is here. The LCM of 9 and 1 is 9. So after subtracting we get 10 into 10 to the power n minus 1 minus 9n. And multiplying this we get 10 to the power of n plus 1 minus 10 minus 9n. This imply this is equals to 4 by 81 into 10 to the power of n plus 1 minus 9n minus 10. So this is the way by which we can find the sum of this series where there is no direct form of the GP. Okay. In problem number 2, we have to find the sum of this series up to n terms. And similar as previous, there is no direct form as GP. Okay, so we have to convert this to our known form. So let us study how we can convert this into our known form. Here 0.6 plus 0.06 plus 0.006 plus 0.006 plus continuing up to n terms equals to, here all the terms are multiple of 6. That is why we can take 6 as the common factor, and after taking 6 as the common factor, we have 6 whole into 0.1 plus 0.01 plus 0.001 plus 0.0001 plus continuing up to n terms. Similar as previous, now we have if we multiply all the terms by 9 and then balance it by division with 9, we get 6 by 9 into 0.9 plus 0.09 plus 0.009 plus 0.0009 plus continuing up to n terms. Multiplying all the terms by 9, multiplying all the terms by 9 and then balancing it by dividing with 9. So 6 by 9, we can cancel this 6 and 9. 2 3s are 3 3s are. We can write 0.9 as 1 minus 0.1. 0.09 as 1 minus 0.01. 0.009 as 1 minus 0.001. Plus continuing up to n terms. Two by 3 whole into, now we can create an arrangement. 1 plus 1 plus 1 plus continuing up to n terms. Here we represent 0.009 by 1 minus 0.001. Similarly, we can represent this by 1 minus 0.0001. Okay, by this way we can continue this up to n terms. And now when we arrange these terms as, we get 2 by 3 whole into 1 plus 1 plus 1 plus continuing up to n terms, and from rest of the terms we can take minus as the common factor, and this will give 0.1 plus 0.01 plus 0.001 plus continuing up to n terms. Summation of these n numbers of 1 will give n, and 0.1 means 1 by 10, 0.01 means 1 by 100, that is 1 by 10 square, 0.001 means 1 by 10 cube, that is 1 by 1000, plus continuing, and the nth by following this, first term is 1 by 10, second term is 1 by 10 square, third term is 1 by 10 cube. So by following this way, we can write nth term as 1 by 10 to the power n. Okay, so this is the arrangement. So now this arrangement help us to understand that this form is a GP, where the first term is 1 by 10 and the common ratio is also 1 by 10. So for this, first term A1 is 1 by 10 and common ratio R is equals to 1 by 10 square divided by 1 by 10, that is 1 by 100 into 10 by 1 is 10. So that is why, and here the common ratio is lesser than 1. That is why to find the sum of this series up to n term, we can use this formula. Okay, that is Sn equals to A into 1 minus r to the power n whole divided by 1 minus r. So Sn is equals to A1 into, here the first term is A and here we consider first term as A1, that is why Sn equals to A1 into 1 minus r to the power n by 1 minus r equals to 1 by 10 into 1 minus 1 by 10 whole to the power n by 1 minus 1 by 10. 1 by 10 into 1 minus 10 to the power minus n by 9 by 10. We can cancel this 10 and thus we get 1 minus 10 to the power minus n by 9. Okay. So this will give 2 by 3 into n minus 1 minus 10 to the power minus n by 9. Nothing is here means 1 is here. So LCM of 1 and 9 is 9. So 2 by 3 whole into 9n minus of 1 minus 10 to the power minus n equals to 2 into 9n minus 1 plus 10 to the power minus n by 27. Okay. So this is the way. That means when a series of value is not in a direct form of a known series, that is GP or AP, then when we want to find the series of certain number of terms, here like n numbers of terms of this unknown series, then we have to convert that unknown series into a known series by this way. Okay, and after converting into the known series, we can find the sum of any number of terms of that series by this way. Okay.